shape scale drawings and models. I can use scales to find actuals.
So we now are, thank you, Eleanor, we have scales, we have scale models, we have scale drawings, and we can use them to find actuals, and we can use them to find drawings or representations, right? Well, I hope so. Scale drawing, two-dimensional. I'm going to skip down to number 4, scale model, three-dimensional. So a drawing is on paper, a model is an actual thing that you can hold in your hand, right? Okay. Ratio is a review. Remember, there's differences between ratios and rates. Rates, you have 2 different units. Ratios, you're comparing 2 different numbers. They can either be the same unit or different units. But if they're different units, they automatically become
Rates.
And then the big one for this lesson is a scale. A scale is, again, a ratio of the drawing to the object. Everyone say, drawing to object.
Drawing to object.
Does that matter?
Yes.
Does that matter significantly?
Yes.
A scale is a ratio of the drawing to the object. So when you get a scale, and it gives you a 2 to 4, I don't have any labels on this. What is this? Is this the drawing or is this the actual?
Drawing.
What is this?
Actual.
Always, yes or no?
Yes.
So now that you know that, no matter what, because no, you're not going to be told this on a test, or an NWA, or an MCA, or an ACT, or an SAT, you know that the first is always going to be the drawing, or the model. Okay? That's very helpful. Reduce, enlarge, or preserve. These were tricky. Number 5, I'm going to refresh your memory if you're watching this right before the test. Every group but one got this one wrong when you solved it together. Tell whether the given scale reduces, enlarges, or preserves the actual. 1 meter to 25 centimeters. The 1 meter represents the what, you guys? I'm going to ask that question again. 1 meter represents the?
Drawing.
25 represents the?
Actual.
What is bigger, 1 meter or 25 centimeters?
1 meter.
1 meter is bigger. So we just drew a representation of 1 meter. We said, okay, that's 1 meter. Even though it's not, we just said it was. And we knew 1 meter is bigger, so we drew a little small representation of 25 centimeters, even though it's not even close. And then we drew an arrow. We said, okay, to go from the actual, because the actual is the 25 centimeters, right?
Yes.
You have to go from the actual to the drawing. And to go from the actual to the drawing, you are getting bigger or smaller?
Bigger.
Bigger. And we even labeled actual drawing, therefore you were enlarging it. Pooja, remember what you said for your cheat sheet idea? And what you were saying is great if you can stick that in your brain. I just don't think most people can stick that in their brain and remember. You were talking about if this one is smaller than this one, you do this. If this one's bigger than this one, you do that, right? Okay, stick with that because that works if that's what you can remember it by. Okay, so you have another example here on the bottom, and then our cheat sheet idea was scales are always set up. The drawing or the model is first to the actual. Okay, cool beans. Skipping on down to real life here. You have a couple of examples. First example, we gave you the scale. We gave you the measurements of the actual drawing, I guess this was. And you needed to figure out the total dimensions. We use scale factor. In this situation, we could use scale factor because we had everything that we needed. We didn't need any missing dimensions. We just needed to figure out how much to enlarge the drawing by. So we need to do enlarge a 3.5 inch drawing, a 3.5 by 5 inch drawing by whatever the scale factor was. So to go from a fourth to a 1 whole, what's the scale, or what's the scale factor? 4. So we multiplied 3.5 by 4, we multiplied 5 by 4, and we had our actual. Yes or no?
Yes.
Okay, down below. So there's your process. Now we were missing a dimension. When we're missing a dimension, we could use proportions. Do you have to use a proportion?
No.
Could you still use scale factor?
Yes.
Yes, you know the scale factor to go from 2.54 to 1, or from 1 to 2.54 is 2.54, right? And so you could either use scale factor to calculate what you need to calculate, or use a proportion like Akshay did. Both of them are going to get you to the same result, in the fact that the drawing or the model was 127 centimeters. I love the cheat sheet idea. This is one of my favorite cheat sheet idea notes of the whole year. I know this is getting long. If missing one measure, this is the number 1. If missing one measure, use proportions. If all measures are known, use scale factor. you're missing one measure, could you actually still use scale factor 2?
Yes.